Hello, this is Dr. Larson. I am going to record some stata coding. In doing so, I hope that you can learn how to do it and have a reference so that as we code these data sets, we're going to go forward. Now, I'm going to go ahead and navigate to our open defecation, so our shared folder here, and then I'm going to navigate to the open defecation file. And here we have two separate do files. We have a compiling women's anemia dataset and a creating, oh, we don't need that, creating health quintile. There should be, let's see here. There should be a manipulating dataset. I'm not finding it. Let's see. Oh, stated do files. So I'm looking at this pathway here. Alright, stated do files, manipulating DHS, anemia. Alright, so these are the two do files we're working on. Start here with our compiled dataset. Now what we need to have is our woman's dataset has the measure of our outcome. And for our maternal health and sanitation, that outcome is woman's anemia. And for our sanitation and blindness, that outcome is literacy. And then part of that, one of the responses to the literacy is whether there were what's it called? Whether the woman could read or not read, or couldn't read because of being visually impaired. Sorry, I just got an email, so I have to turn my email off so I stop getting distracted. Okay, so in our doof, so that's our women's data set. Now, problematically, our exposure is community level sanitation. That's from the household level data set because we want information from houses that may not have women in them. Their access to sanitation will still impact the women next door. And so we need to go through and create our measure of exposure, that's community level sanitation, from a household data set, match that up with our woman's data set, and we need to manipulate our woman's data set so that we have a simple data set. So we're going to start, this one in Albania is done. So you're going to start and open up this this data set in Albania. You can see here the path files are for a PC, and I'm on the Mac, and that's just the joy of using a Mac. So I'm going to go through and find this data set from the survey datasets. So Albania 2008-2009 household file. So I open that up here into my stata. Taking a minute here. Let me see if I can close some other programs that are running right now to free up some memory. Alright, so here's my Albania household dataset. You can see that there are a host of variables. You know, all these variables on the right hand side over here, you scroll down, see that. If I type browse into my command line, it opens up the dataset, kind of the flat file, and you can see that all these variables, a lot of it's just missing information. We don't want this in our compiled dataset because we have like hundreds of countries to add together. What we want from this household level data set are two things. The first thing we want is what's the level of access to sanitation in the community, and the second thing that we want is what's the level of wealth in the community. So I'm going to run a look for toilet, and that's going to bring me back all the variables that have toilet in the label. And so we have the type of toilet facility that the house uses. And that's the variable I like. So HV205, I'm going to tab that and see what the frequency is. Now you can see there's lots of different types of toilets. You have flush toilets, whether it goes into the sewer system or a septic tank or it goes to a pit latrine. You also have some where they don't know where it goes. These flush toilets that go somewhere else or not even knowing where. Then you have different types of latrine, a pit latrine, Here, with and without a slab. What we're particularly interested in is this no facility, the bush, or the field. And then you have composting toilets and bucket toilets and others. So I'm going to run a tab again on HV205, and I'm going to put this option no label. I'm going to say comma no label. That's going to return the same table, but instead of having these nice labels that are descriptive, it's going to tell me how the data are coded in stata. So you can see here we have 4,994 observations with a code of 11. Up here we see that 4,994 observations was the flush to a pipe sewer system. Then I'm going to scroll back down here. What I'm really interested in these four, this no facility, bush, or field, and they are coded as 31. Okay. So now I'm going to create a new variable, no toilet equals 1. And this variable is descriptive. I want it to be 1, which and when we look at 0 and 1 variables, we often have 0 coded as no, 1 is coded as yes. And so this variable, no toilet, does the house have no toilet, equal 1 if HV205 equals 31. Right. You can see this on line 8 of our do file right here. That's that first line. We then replace no toilet equals 0 if HV205 is not equal to 31, and there might be some missing there, maybe not, but there might be. And so we say if the toilet variable is not none or bush or field, and the toilet variable is not missing for this house, replace it as 0. Okay, and then we have this line 9 in our do file. Now we can run a crosstab on this. HV205 and no toilet, that'll give us a crosstab where we have each level of 205 and whether it's coded as 0 or 1 in no toilet. What we're looking for is to make sure that these rows do not contain values in both columns of no toilet. If they have a flush toilet, they have a toilet, so it should be all 0 as it shows here. If they have no facility, they do not have a toilet. It should be all numbers here in the toilet and 0 here in the no toilet. And so this looks good. Okay. Next, I need to get the proportion of houses in each community with sanitation access. Now remember, these are two-stage cluster samples. So first they sample the community. And so their community is the cluster number, this HV001 up here. If I tab that, I see that some clusters have 18, 20, 17. Looks like one has 14. So it looks like it's up to 20 houses in each cluster. And some less. All right, and then we keep going down, we have 450 separate clusters. All right, so we have 450 communities. Now, we're going to use the egen command. Egen is a very powerful command. If you type help egen, it will bring up the help file for this command egen, and you can do lots of cool stuff. One that we can do that I like is this mean. Okay, it creates a constant, it creates a value of mean of some variable. Now our no toilet is coded as 0s or 1s, and so the mean of a 0-1 coded variable is actually the proportion. And so we're going to have egen, and we're going to say open defecation equals mean no toilet, comma by HV0s or 1. What we're saying here is create us a new variable called open defecation. We want this new variable open defecation to equal the mean of the no toilet within each cluster. And if we tab open defecation, you have the vast majority have 0 complete access to sanitation in Albania, and these other ones have just limited, right? The next variable that we want to create is a community level variable. And so if we run a look for wealth, or community level wealth, we have this wealth index, and it's coded as 1 through 5. Right? So you have the poorest up to the richest. The poorest is coded as 1. And remember, I just did a tab of HV270, comma, no label. After a tab of HV270 gives us the labels. And 2 coded as poor, up to the richest, coded as 5. And we're just going to take the mean of this one, of this wealth index, by HV001. So we're going to create a new variable called community wealth equals the mean of HV270 by HV001. So give us the community wealth, the mean of this wealth quintile within each community. We do that. All right, so we've done lines 7 up through 11. Now those are the two variables we want from the household level data set. So now we need to match up the household level data set with the woman's level data set. And we have some unique identifiers. So the houses are uniquely identified by the cluster and the house number. So if we tab HV002, you see there are lots of houses, almost 400 houses that are household number 1 and household number 2, right? But together with the cluster number, there's only one house. If we look at cluster 1, then we see there's only one house for each household number, up to 20. And so together those two are unique identifiers. We can double check this by looking at the duplicates command. And I'll type help duplicates. Duplicates reports, tags, or drops duplicate observation. And so let's see if there's any duplicates. We'll say duplicates report HV001, HV02. So let's just look at household number. Let's see if there are duplicates. And there's a lot of duplicates. 389 copies. 392 copies. There's some with 409 copies. But if we combine HV02 with HV001, then we have only one copy, no surplus duplicates. Right? So it's a very unique identifier. And so we're going to use HV001 and HV002 together. Now in the mother's file, these variables don't have the H. They're only V's. So we're going to rename them. So we're going to say rename HV001 into V001. We're going to rename HV002 into V002. And that way they're the same as the mother's file. And you can see this in line 12 and 13. We're going to get rid of all this extra data. So we need our identifiers, our unique identifiers. We want the data we created in community wealth and open defecation. And so here I'm telling stata, keep these variables, get rid of the rest. And if you remember what it looked like before when we browsed, now we just have 4 separate columns. Very simple. No missing data. Ah, nice. All right. Then we merge. So we're going to go up here, data, combine data sets, merge 2 data sets. Now we're merging one to many. We have one house for all the women in that house. So we have one house to many women on key variables, and these variables are V001 and V002. And we're just going to navigate over to our data set, wherever it is. Survey data sets. We're in Albania. Albania mother's file. And we push OK. Merging. My computer is going slow. Okay. So now we merge these two and we get some feedback. The result of the merge, we have 2,435 observations that were not merged. We see this is from the master. In this data set, the household file was open, and we merged it to the mother's file that was not open. So the household file was our master, and the mother's file was our using. So this means we have 2,435 houses that didn't have a mother or didn't have a woman of age 15 to 49. That's fine. We're just going to drop those. From the using, we did not fail. We succeeded in matching all of the women to a house, and so that's good. And then we have here 7,584 women who were matched to the house. Good. All right. So now I'm going to say drop if merge equals 1. Okay. This is the variable that was created, this merge variable. This is equal to 1. This one is equal to 2. This one's equal to 3. So we're getting rid of all these houses without women because they don't have information on whether they have anemia or not. So we drop them. And then we're going to just drop the variable merge as well. And that allows us to merge later. No problems. All right, you can see we dropped 2,435. There were 2,435 up there. Cool. So you can see that here in these lines 15 through 17. We merge, drop if merge equals to 1, and then drop the variable merge. Next, you have this other do file in this line. Because if we browse this woman's data set, we have so much junk in here. How many variables is this? But look at all these columns. All these columns we're not going to use. And it's different stuff. You know, like, let's kind of take a look at it. I'm going to see if I can expand this. So we look at these variables, these labels. All right, we have stuff like, does a house have a radio? We have stuff like the birth column order, the birth order, all these things about the children. It's the child's a twin, the month of the birth, year of the birth, all these things. And this stuff, it's not relevant to this anemia question that we have. Okay. And previously, we've created our conceptual framework where we've understood that anemia is can be caused by illness such as malaria or parasitic infections. It is also caused by lack of diet or poor diet, lack of food security. And we know that women who are wealthy have better outcomes. We also know that women that have higher education have better health outcomes. So there's a number of things we want to keep. This do file here, this manipulating DHS anemia do file, that is going to take this entire woman's data set and keep the stuff that we want. So in this do file, we have our wealth, household wealth. We have a primary education or not. Okay. We have our controlling variables, our age. All right. We have our age. We have our parity, whether the woman's had a birth in the last 5 years or not. We have whether the woman is pregnant. We have our educational level. We have our diet, and our diet here, wasting and stunting. This is the weight for height. So is a woman too skinny? And the stunting is the height for age. Is the woman too short? Which would be an indication of chronic malnutrition as a young child. We have the mosquito net here, whether they're using that. A mosquito net we know protects against malaria, and malaria causes anemia. And then we have our anemia here. Now this do file is not yet done. As you can see, some of this stuff looks good, some of it doesn't. Alright, so let's start with our matching variables here. We have our community wealth. That's fine. We kept that. We have our community surface water. So we did not create a surface water data a variable from our community. So let's go back and do that. So we're going to clear out the data we have and reopen our household file from our Albania, and we'll create a community surface water. It's trying to move. Alright, so I'm going to run a look for water. And we have source of drinking water is this first hit, HV201. I push Q to break that because I don't care what else has water. So I'm going to say tab HV201. We have all these different labels. Alright, we have piped, we have wells, we have springs, then we have this one called river, dam, lake, pond, stream, canal, irrigation. That one is surface water. We have rainwater, tanker truck, cart, bottled water. Okay, so we tab HV201 no label to find out what these two observations are. And by understanding that, there's this rainwater also has two, but this one will come first, and it's 84.62 cumulative percentage. So I'm going to look for that 84.62. So surface water is coded as 43. All right, so I'm going to say generate surface water equals 1 if HV201 equals 43. All right. Then we have excuse me. We have surface water to 1, and now we got to get our other zeros. So we replace surface water equals 0 if HV201 does not equal 43 and HV201 is not missing. Okay. Now I'm just going to copy and paste those into our do file here. Oops, wrong button. Okay. And then again, we have surface water per household, but let's get surface water over to the community. So we're going to use this egen command. So egen community surface water. Or first let's tab, we're going to run across tabs. So tab HV201 surface water. And here we're just double checking. So all these piped wells, protected wells, they're all coded as 0 for surface water and not coded as 1. But the surface water variable, river, dam, lake, ponds, that is coded as 1 for surface water and 0 for not, right? So we are looking at this. Looks really nice and neat. We're looking good, all right? So now weegen community surface water equals mean of surface water within each community, all right? And then if we tab community surface water, you notice we only have 2 houses that have surface water, but we have 35 houses, 20 plus 15, that live in communities where at least somebody gets their water from the ponds or the rivers or the lakes. Okay, so I'm going to copy this variable here over here to our do file. Okay, then I'm going to add community surface water here. All right. Then I'm going to rerun my merge. Taking time. Take its time. No room to add more variable. This sometimes comes up. I'm going to set the max var at 32,000. I'm going to say permanent clear set max var 32,000 permanent. Good. Now I just have to go through this again. Now if I'm on a PC, I would just rerun my do file here, but I'm on a Mac, so these pathways are wrong. I didn't want to change the pathways because I'm lazy. So I'm just going to go through this. What is up with my computer today? Let's see let's close Firefox, see what that's doing. Close Adobe. Maybe it's because I'm recording it slow. Close the equation editor. I don't want to close that. I've got a document open. Manually we can leave open. Okay. So now I'm going to highlight this stuff and run it all. Got that. Then I'm going to merge again with the woman's file. Alright. I'm going to run these two things. Good. Now I go to my manipulating DHS dataset. Alright, so we have community surface water is good. Community wealth is okay. Our household wealth is available in the mothers. For matching, we want to generate that as rich or poor. Alright, so matching variables. So I'm going to just get rid of these 2 lines up here, make this nice and neat. A little bit anal about the way my do files appear. The do file is a very good note taker for you, so you can understand what you're trying to do, understand what you're doing. All right, so the community wealth created in the household data set as the mean of wealth quintile by cluster. Okay, excuse me. Community surface water created in household data set as the proportion of houses in each cluster using open water source. Okay. So community birth at the birth center. So we're going to create that at the mother's data set. So let's look at that. So I'm going to run a look for birth. We have a lot of variables. Respondent's mother's year of birth, birth column number, birth order number, month of birth, year of birth, date of birth, preceding birth, and succeeding birth, and live birth. Live births, age of respondent, marriage, entries. So we're looking for the place of delivery. Weight at birth, last birth, C-section, index to birth history, day of birth. So I'm going to look for delivery. Place of delivery, M15_1. So now the thing about the DHS datasets is you see this variable has an underscore in the name of it. So that means we have a place of delivery information for 6 separate observations per 6 separate things per mother, six separate children. We have the first child, second, third, fourth, fifth, and sixth. All right. So I'm going to tab M15_1, and that gives me information on whether the baby was born in a respondent's home, in a public hospital, a public health center, Tirana maternity, other public, or a private hospital. So these would all be at a facility. Respondent's home would not, and then some type of other that we wouldn't categorize as a facility. All right. If we tab M15 underscore 2, we have more information. And tab M15 underscore 3, a few more, few more, few more. And I think what happens with these M variables, underscore 1 through 6, is it's within the last 6 years. So this underscore 2, these are the twins. We have 256 twins, or 253 twins. Then we have 18 triplets and 3 quadruplets and 1 quintuplet. I think, I'm not certain. Don't quote me on that. But we're just going to concern ourselves with M15-1. And we're going to do the same thing we did previously, is first we're going to generate no facility delivery equals 1 if, well, first we tab M15-1, and then we do with no label. Right. And we see that the respondent's home is this level 11. Now we're working in Albania, where there's actually pretty good access to healthcare. So we're going to switch this up. We're going to go to somewhere else, because Albania is too rich. It's not poor enough to have issues that we are interested in particularly. It does have its struggles. So let's go to Cote d'Ivoire. Cote d'Ivoire sounds like a good place. And we're open up the mother's file here. Not going to save it. And I'm going to look at tab M15 underscore 1 here. You can see here we have respondents home. 38% of the women gave birth at home. But other people gave birth at somebody else's home. And that's an important part. So now, and somebody else's home is not a birth facility or a health center. So we see that somebody else's home is coded as 12. Then it jumps to 20. And this is a common way of coding variables where you have like situations together. So you can notice all these 20s are going to be hospitals, right? They're government hospitals, government health centers, government health posts, the public sector. So 20s are the public sector, and then you have the 30s that are the private sector, private hospital or other private sector. And then 96 is coded as other. So I'm going to say gen no facility delivery equals 0 or equals 1 if M15 underscore 1 is less than 20. Because we know that 20 is the cut point here. So let's get this 12s and the 11s. I don't know if there's anything else ever coded besides someone's home and someone else's home. So we get that gen no facility delivery equals 1. Then we replace the zeros. Equals 0 if M15 underscore 1 is greater than 19. We want to include 20. And M15 underscore 1 does not equal dot. Right? And I'll show you why. So tab M15 underscore 1 missing. We see that there are 4,645 women who actually never gave birth. They don't have information on this birth variable. All right. So this variable at birth, we're going to say copy it here. No facility delivery, excuse me there. Nose is itching a bit. All right. So now this community level variable here, let's separate it. Community birth at health center created from mother's data set. So this is proportion of women giving birth at any health center within cluster. So then we use, again, our egend command. Egend community no facility delivery. And that's a long word, a long variable name, but it's also very descriptive. It tells me that, yeah, no community facility. Some people use underscores. I hate typing underscores, and so I don't use them, because when you have to type the variable name, I just like to type letters because I'm lazy. So community no facility equals the mean of no facility delivery within each cluster. Then if we tab, you see that there's some clusters, 15% of them, that they all delivered in a health facility. And there are other clusters, almost 2%, where everyone delivers at home. And then others where it's 90% at home, 50% at home. So the one thing I forgot to do is a cross tab, M15 underscore 1 and no facility delivery. So here I'm looking for this nice pattern. So everybody that gave birth at a home is coded as 1 in no facility delivery, and everybody that gave birth somewhere else is coded as 0 in no facility delivery. Alright, so I'm just going to copy this command over. Good. So now we have community birth at health center and the proportion of women giving birth at any health center within the cluster. Household wealth. So this household wealth, now these are our matching variables. We have community wealth, community surface water. So what we want to do is we want to do exact matching, and so we're going to match women exactly on the same covariate patterns. So if they're in the same, so if you look at our community, if we scroll up here, and you look at our community level facility delivery, there's a lot of covariate patterns here, and so we're going to separate this into tertiles. And the command we're going to use is the xtile command. So if we type help xtile, gives us quantile categories. Now, this is a really nice command. A tertile means it will have 1/3 of the observations in one level, 1/3 in another, and 1/3 in another. And so if you look at our tab of health facility births, we'll have 33% in one level. These women would be grouped together as the first tertile. Then we'd go up and we get up to 66% of the women. Going down, going down. So these women would be the second tertile. And then this one would be up to 100%. And you can see that this will allow the covariate to vary depending on access in the survey. But it will collapse the categories nicely. It collapses based on the data. So I'm going to say xtile. The new variable is facility delivery tertile. No facility delivery tertile. Equals community no facility delivery. NQ, number of quantiles, equals 3. So if we tab no facility delivery tertile, we have 3 separate and it's all balanced. 1/3, 1/3, 1/3. If we tab no community delivery, no community facility delivery, and community, oh goodness, these are variable names. Community no facility delivery and community no facility, no facility delivery tertile, then you can see that, yeah, all these women are coded as the first tertile. Right? They have high levels of facility deliveries. And then the next tertile is the next one, so all these women as the next. And then the third tertile there. Okay? So, copy that. So we're going to categorize this into tertiles for matching. And surface water, we're going to do the same. Xtile, community, water, tertile equals community, surface water, and Q3. And wealth, we're going to do the same. So I'm just going to copy these commands. Here I'm just telling myself notes so I can come back and say, like, we did. This is what we did, especially when we write the article or when people, when it goes out for review. All right. So we have community wealth, community surface water, community birth center, birth health center, household wealth, categorized as rich or poor. Okay, so we're going to categorize this household wealth as rich or poor within the data set. So we're going to look for wealth. We have 2. We have the wealth index. That's our quintiles, 1 through 90. And then we have this V191, which is the factor score. And this, you can see it goes from negative 150,000 and it'll go up to positive 400,000. But if we sum this, 159, and then we sum it with detail, we can see the median is 2,990. So we're going to create a rich or poor based on this. Okay. So our household wealth, we're going to say xtile rich equals V191 and Q2. I'm going to say rich poor. Alright, if I run this, then we have just half the observations with level 1, half with level 2. And then if we tab, oh, it doesn't work because like that. Oh, okay. Well, it's not working either. Oh, well, we can do the mean. Alright, so our mean of our level 1 is a negative, and our mean of level 2 is a positive. So we have half and half in each one. One coded as poor, poorest, as below median wealth. Two coded as above median wealth. One is high access to facility delivery. So I'm just adding my notes here. So that's our notes, how this is coded. Let's code these. 2 is medium access to facility delivery. 3 is low access, poor access. So same thing here. Is 1 is, I don't remember. We'll have to come back to that. Okay. Alright, so we have community birth, health center, household wealth. Now we have mother's education, completed primary or not. So here I'm going to look for education. We have highest education level is V106. It has no education, primary, secondary, or higher. But there's also this V149 is educational attainment. Aha! And we have here no education, incomplete primary, and complete primary. So it looks like to me, and we can double check this, that yeah, when we look at educational attainment in V149, we have completed primary here, but that's lumped in V146 as primary here. Okay, so we're going to say our primary education is 0 if V149 is not missing. All right, and here it's 0 coded as incomplete primary or no education. 1 coded as completed primary. And then it's 1 if that is greater than 1. Alright, so I tab V149 and with no label. 1 is incomplete primary, so we want it greater than 1, but also to make sure if it's not that it's also not missing. So mother's education is done in terms of matching. So that's our matching variables. Those are done. Now let's make our controlling variables. We'll add some more asterisks so it's nice and pretty. Cool. Alright, so the first one we want is age. Now this is age of the mother. And we are looking at, in maternal sanitation, we're looking at, trying to think the best way to do this. So for the open defecation, the community level sanitation, and maternal health, if we're looking at neonatal health, the age of the mother matters for a birth, for a child's survivability at birth. Younger mothers are less likely to have a child survive, and older mothers are less likely to have a child survive. So we usually categorize this as less than 18 years old, 18 to 35, and then greater than 35 years old. But for anemia, it might be different. Anemia might more be related to lifespan issues, where we have younger women being in households with their fathers and mothers, and then the new wives, and then the established wives, and the babies. And so I'm thinking we just want to categorize this as 5-year increments. And let's take a look for age. Age, and so we have a current age and then an age in 5-year groups. And these 5-year groups are kind of nice. And so we're just going to use them. Alright, age of the mother in 5-year groups. Gen age equals V013. Then let's just let's do this 1. We're going to just write ourselves a note. Say like 1 is coded as 15 to 19. 2 coded as 20 to 24. 3 coded as 25 to 29. 4 coded as 30 to 34. 5 coded as 35 to 39. 6 coded as 40 to 44. And 7 coded as 45 to 49. And then there's nobody older than age 49 because this survey only looks at women of reproductive age and it goes up to age 49. Alright, so our age is good. Now let's look at parity. And so parity is going to act on anemia because women who give birth are growing a baby are growing a baby inside them. And so if they've given birth recently, they've had nutrients go out of their body into the baby. So we have here that we've categorized parity, how many births a woman has in the past 5 years. 0 coded as none, 1 coded as 1 birth, and 2 coded as 2 births. 2 births or more. I'll just get rid of that. And then if you look at this V209, it's births in the past year. Well, that's just the year. We want 5 years. So let's look for birth again. I thought that was last 5 years. I'm confused. So V208 is births in the last 5 years, and V209 is births in the last year. So we're more concerned with V208. And here you see that some women have not had a birth in the last 5 years. Others have had some up to 5. So we have parity equals V208 and replace parity equals 2. So here we generate parity equals V208. And it's just this perfect correlation. But here, let's just take all these women here with the higher parities and we'll take them into this level. So we're going to replace parity equals 2 if V209 is greater than 2 and V209 does not equal missing. V208, I'm sorry. Not V209. So now we tab V208 and parity. We have, here's our parity. All these women that have 3, 4, 5 births are coded as 2. And we do that for statistical purposes. There's only 4 women here that had 5 births in the last 5 years in this data set, and so it's not very informative. We can't really control on it. Okay. And then let's look for a pregnant. So we look for a pregnant. We are currently pregnant, V213. So pregnancy, yes or no. We tab V213. It's no label. And we're going to call this pregnant because pregnancy has more letters. 0 coded as no or unsure. 1 coded as yes. We're going to generate our wealth. And this is just going to be our wealth quintile. So V190. 1 coded as poorest. 2 coded as poorer. 3 coded as middle. 4 coded as richer. 5 coded as richest. Okay, you might realize that we matched on wealth, coded as above and below the median, but here we have the wealth quintile, so we'll control on it again. Then we have mother's education, or we'll say woman's, because we have, what's it called? Women who are not mothers. 0 is none. 1 is some primary. 2 is completed primary or higher. Okay, and if we look for education, we see we have that V106, but that doesn't have our incomplete primary, but V149 does. And so we'll look at V149, no label. We have 0, no education. 1, some education. An incomplete primary education. 2, completed. We want all these women who have higher degrees than primary education, that they get coded as 2. So they're educated. So we have gen education equals 0 if we've 149 is equal dot. Then it equals to 1 if it's greater than 0. So no education, so incomplete. Then if it's greater than 1, equal it to 2. Good. All right, next we're looking at diet and wasting. And wasting is a measure of acute malnutrition or acute food security. All right, and so we're going to say here, not wasted, BMI at 18.5 or above. And we had some chat about this. Anu and I had some chat thinking about this. The weight for height is basically a BMI for adults. For kids, it's a little bit different. So we're just going to use a BMI. Moderate wasting, BMI 17 to 18.5, and then severe wasting, BMI less than 17. All right. So we create this new variable called BMI, and I'm going to change this from that to food security. All right, BMI is 445, and so if we look for BMI, they have this variable BMI standard deviation. Look for body mass index, this V445, and I want you to check closely on this for each of the data sets we use, because I don't know if this is actually going to be there for all of them. So we tab V445. It's actually floated, and it's floated 2 decimals. So this is 1,266. Nobody has a BMI that big, not even Jabba the Hutt. And so we would have here a decimal goes 12.7. So this woman has a BMI of 12.7. All right. And so we start out here with 0, and then we're going to say less thans are nicer than greater thans for stative. We're going to say if it's less than 18.5, but it's not decimal, it's 1850, and then less than 1700. Let's just run that and kind of see. So we have 77 women who are severely wasted, and these ones are moderately. We might revisit this. This is not all that informative because 93% of these women are normal BMIs, so to speak. It's not the best measure of food security. So the next one we have is V438, and it's a height in centimeters. And so we're going to categorize their food security as stunting as 0. 0 is not stunted, at least 2,000 centimeters or 200 centimeters. And 200 centimeters, let's see, go to Safari. 200 centimeters is pretty small. 200 centimeters is 6.5 feet, so that's not what we want. 150 centimeters is 5 feet. Oh, because I guess here we're excluding all the women that are reportedly as too big, right? And then here it's at least 150 centimeters, 4.9 feet. And then 1, it would be stunted, 4.9 or smaller than 150 centimeters. Right, so these women are relatively small. Okay. So this is gen stunted if it's there, if it's less than 2,000. If you look at this variable 1438, you see that it stops at 1992, then you have not present, refused, and other. And if we tab that with no label, those are categorized as values. So it's 9,994. And nobody's that tall. That's like 100. What is that? 1,000 centimeters tall. Is that 1 kilometer? Is that a kilometer tall? Maybe not. How much is 1,000 centimeters? 32 feet tall. That's crazy. There's nobody's 32 feet tall. All right. So we just make sure it's less than 2,000. Replace it as 1 if it's less than 1,500. All right. Then we have mosquito net ownership and use. 0, house does not own. Okay. 1, the house owns, but the woman did not use. And then 2, woman used last night. Okay. So if we look for a mosquito, and not all data sets will have mosquito net data. So we look for our mosquito. We have ML101. We have no nets, the type of bed net that they slept under last night. And then this V459 is, do they have a mosquito net? All right, so generated mosquito if 0 equal if V459 equals 0. So they don't have a mosquito net. Replace mosquito net equals 1 if V459 equals 1 and ML101 equals 0. So they have a mosquito net, but the woman did not sleep under it. And replace the mosquito net if 2 if ML101 is greater than 0 and ML1 does not equal missing. Because if we look at missing, this one doesn't have any. Anyways, so we have that mosquito net, and then we have our outcome variable, moderate or severe anemia. And then here we look for anemia. We have V457. Anemia level severe. So we have moderate or severe anemia, levels 1 and 2. So we're going to say here, this needs to be greater than 2, so it includes 3. And this would be less than 3, so it includes 2. All right. And the way to check that, anemia, can't generate anemia and then generate it again, so it needs to be replaced. And then we have we cross tab it. I'm going to change this name to mod sev, anemia, moderate or severe. Alright, so I'm going to say here, so I'm going to create this any anemia is 0 if it equals to 4. So I'm going to say any anemia equals 1 if that's not missing, and 0 if V457 equals 4. Alright, that is everything. Bam. So that manipulating DHS anemia is done. So I can come back here. So we run this, line 21, run that. We'll make sure it doesn't bump. Then we keep all our stuff that we want. We didn't keep the urban. This is going to need to be amended. So let's run this for our Cote d'Ivoire. So open up the Cote d'Ivoire household level data set. That's just line 7. Okay. And then we're going to generate our toilet stuff. First I'm going to tab HV205. So they have no facility, no bush. See, they have 34.5% of the houses have no facility. Okay. A lot different than Albania. So we're going to keep all this stuff, or run all this. Alright. Looks good. Then we're going to merge. Remember, it's many to one on V001, or it's one to many, I'm sorry. And we're going to merge from the mother's file. Come down here to Cote d'Ivoire. Mother's file, merge it up. Take a little bit. Cool. Then I'm going to drop this stuff. Good. Then I'm going to run my do file. Oh, I have an issue. Mother's education invalid IV. Oh, I have an if instead of if. So I'm going to look for if. Oh, if space. All right. So that bounced. That's fine. So I'm just going to highlight here and just run the rest of it. The rest of it ran okay. What I did not do is I did not create a blindness variable. So I'm going to say blindness. And this is for Idris. So V457 literacy is V155. Alright, and so this V155 is blind here. Alright, and then these folks are not blind. So these ones are blind. Alright, so blindness here, 0 not blind, 1 blind. Gen blind equals 0 if V155 does not equal missing. Replace blind equals 1 if V155 equals 4. So I'll just run that as well. Alright, so these women who are blind or visually impaired are all coded as 1 for blind. Everybody else is coded as 0. Good. Alright. So ran the do file. Bam. Then we got to keep our things. So we're going to get rid of a lot of crap in this data set. So we're going to keep V001 through community water. And then we're going to keep case ID. So let's say case ID. The case ID is a unique identifier for the woman. Alright. And I did that, so I want to keep these 5 variables that are created. Get rid of the rest. Now if you notice, all the variables we create are down at the bottom. So we can actually create this variable through, or keep this variable through here, and we have everything we want. So we're going to say, what's this variable called? Community wealth tertile. Through blind. The other variable we want to keep is V025, which is urban rural, which is a big important indicator. Alright, so we keep that. Okay. So this has worked. This data set's done. And now if we browse it, we have our exposures, open defecation. We have our outcomes, blindness, anemia. We're ready to go. And we have all our variables we're going to adjust for. So this data set's ready to go. Okay. Now you might be confused because why am I doing Albania? So maybe do that real quick. So this is Cote d'Ivoire. I'm going to use, where's my use? I bring in the household file. Okay. Then I run my script here. Then I merge. And this is the 2011-12 DHS. Okay, then I merge, and then I run my script here. Then I run my do file. Then I run my script here. Now, I have to change the name. Country name is not Albania. And this is the 2011 to 2012. Right? Then I save. So I'm just going to run all this. Make sure it runs. Ran 5. Then I'm going to save it. I'm going to save as in the open ODF and stunting, open defecation, maternal health, state of women's data set. I'm going to save it as 2012 DHS Cote d'Ivoire. I'm going to say replace. So this data set's done. All right. Now I'm going to, from there, I'm going to copy this. So 2011, 2012. And we also, because we also have, well, first I'm going to go to my list of surveys included and see if there's any other Cote d'Ivoires that are included for our anemia or our blindness, either one. So there's only Cote d'Ivoire, so I'm not going to copy it. So it's just one. All right. So now Cote d'Ivoire is done. I'm going to copy that whole thing, paste it, and then revise it for the next survey. So hopefully this is useful for you, and it can guide you as you create, as you go through, and let's make this data set. Let's get this compiled data set done by the end of the year, I think, for anemia and blindness, so that we can start analyzing. And then for maternal health, we actually have to create the neonatal 2 files as well. So this is the end, and yeah, thanks for all your work, and let's get some work out and be good.